Hello everyone and welcome to the Templafy Engineering channel here. Today I have here our CTO Thomas, and Thomas, would you like to explain a bit to us what's the idea behind this channel project?
Yes, I definitely will, and we are quite excited to kick off this channel. The idea is that we want to show how we built Templafy. You may not know Templafy, it's a SaaS product and we have a lot of big enterprise customers. It's hosted in the cloud, but this is not about our product, this is how about we built our product. And the idea behind the channel is that instead of showing a lot of demos of the different tooling we are using, we want to show you the real thing. So we want to show you the real software development lifecycle, our real data platform, our real end-to-end test. And we have a lot of great tooling and techniques that we are using. So instead of you going to YouTube and pick off the different tools, we want to see how all these tools fit together in one big, beautiful setup. I hope you will see that at least.
Very nice. But today we're going to talk mostly about Azure DevOps, right?
Yes. So in this very first episode, we want to show you our software development lifecycle, Azure DevOps. And as all companies, we are running Agile, we are running DevOps, and we are fully aware that DevOps is much more than just the tooling and CI/CD. DevOps is about the processes, it's about the people, but this is about showing the tooling. So what we will show you today is our Azure DevOps software development lifecycle. And what I'm showing you here is actually the dashboard that we have running on, that we have hanging on the big screen in the office. And what you can see is that every single team, every single product team can see how many active features they have, how many stories they have in the current sprint, and how many stories they closed. So these
are those are live, right? This is a real deal.
Yes. So this is real time updated, and every single team has a column where they can see the status of their current sprint. And if you scroll a bit to the left, you can see the platform teams, which are serving the product teams. And you can also see status of our build, and you can even see there's a failing build down here.
Yeah, it happens.
It happens. So you can see this is not fake, this is real. If you scroll down a bit, you can see a historical overview of the stories we closed. We closed 42 stories on average per sprint across all teams. Average cycle lifetime is 10 days. You can see we fixed 110 bugs this year, and the lead time is 7 days from a bug is reported until it's fixed and running on production.
That's a good number, right? All the engineers are doing a really good job on that matter. We have been improving a lot.
Yes, as you can see actually up here, this is how the bug have evolved over the last year. So I think a year ago we had 100 bugs, and now we are down to 26 bugs in our system. So there's really a lot of focus on the quality, and we'll come back to why, because we do a lot of deployment, so we really need to focus on quality.
Cool. So let's see in the team scope how it's working now.
Yeah. So let's start by just having a quick overview of DevOps, Azure DevOps. So there's an overview. I just showed you the dashboard. Then we have some boards where you can see work items and backlog and sprint backlogs. We'll come back to these repositories. This is our Git repositories, like files, pull request branches, and so on. And we will also show you our build pipelines. But let's start by actually go into a backlog or a sprint board for one team. So I believe this is the Engage team that you are manager of.
Yeah.
And what we have here is a story, and a story is broken down to different tasks. And every single one of these tasks is actually a deployment to production.
So every time that you make a change, should be ready to go to production, right?
No, we follow the DevOps principles. So and the lean principle about small batch sizes. So every single task is all the way to production. And let me show you how this happens in a safe way, where we can still make sure that we don't compromise on scalability, security, and all those things. So
by all means,
if we take this task here, which you can see is deployed 2 hours ago, what you can see here is that there's some development artifacts. And if I click on this one, I will go to the pull request that's behind this task. So this is the pull request, and this is how it looks in DevOps. I can see that it has been approved by Michael and Imladen. There's some setup that says, because this is a change to the Engage system, it's a tool we have, a module we have, the Engage team must approve it. So no other teams can go and deploy your system. And if we just quickly look at what was in this pull request, you can see this is something about some keyboard shortcuts. And it's not very big, like 2 files changed. And this is one deployment all the way to production, even though it's very small.
And what's the benefit that we are doing those tiny changes to production, like instead of piling up a few changes?
So there's multiple benefits. It all ties back to some of the lean principles about small batch sizes and fast feedback. So you can imagine when we release something like this, it goes to production. Let's say that we introduce a bug or maybe even an incident. The great thing is that if we only released 2 small files and now we have an incident, how fast do you think we will discover it? Rhetorical question. Very fast. If we batch it up in 2 weeks, there will be a lot of code changed all over the system, and it will be much harder for us to identify what broke the system, and hence also take much longer for us to fix it. So small batch sizes, even though it's well, I don't know if it makes sense. It's quite not intuitive for most, but it actually is a more safe way to release software. So, but to make sure we are not too, over ambitious, we have a lot of checks for every single deployment. So first of all, of course, the build must run and the unit test must pass. But we also, before we merge it down, we deploy it to a feature environment. So I will click in here, and what you can see is that here we are running some end-to-end smoke test on a feature environment. So we take all the different systems in Templafy, microservice, if you will. We call them self-contained systems because they're slightly bigger. We have 14. And this is something like account management, user management, authentication. And then if I scroll down to the bottom, you will see you have Engage. This is your system. So we take the latest build from that is running on production of all the other systems. Then we take a version of your system with the small little change we did, and we deploy it to a feature environment running in Kubernetes, exactly the same as our production environment. It's all handled with Terraform, so we know it's exactly the same types of servers, it's the same type of message spots, everything is exactly the same. Then we run some smoke test, which makes sure that we didn't break any of the other systems. And we run some other end-to-end tests, which is specific for the Engage team, where we go into nitty-gritty details and make sure we didn't do any regression tests in your system. So that way, we now have the really good feeling that this is probably not going to fail on production.
And exactly that what brings us the maturity and also the bulletproof safety that we have to deploy to production every change, because we are covered with all this infrastructure and tests and all the way, right?
Exactly. And as you can see, these are required steps. So there's literally no way we can skip these. So even if we have a production incident, we don't skip the test. We still go through all these. So let's continue and see some of the other things we have here. First of all, there must be a work item linked. I showed you the work. We actually started from the work item. So you cannot deploy without having a work item, which means in turn that we have full change management on who did the change and who created the change request, when was it merged, and so on. We'll come back to that. Obviously, if there's any comments on the pull request, they must be fixed. And then finally, we have a very interesting thing here with a quality gate. You can see it's optional. Most of the other teams have it required, but in your team, it's optional. And if I open this quality gate, I go to a tool called Sonar Cloud. It's a software as a service, cloud service, where we run a lot of static code analysis tests. So we test for bugs. It could be a division by 0. It will not make the code not compile, but it will be a runtime bug. It can also be more complex than that. It could be code smells if you have too much cyclomatic complexity or too many
or
parameters.
duplicated code, right?
Well, actually, there's this thing down here about duplicated codes, which is
okay.
tracked separately, because sometimes it's okay. And as you can see, there's some security checks. It could be something like us using an MD5 hash, and that's not really secure, or some security hotspots. Just, okay, here we are actually using encryption and just make sure that, pay special attention. And the really cool thing is, if Sonar Cloud finds any code smells or any of these, it's actually going to annotate it back to the pull request in Azure DevOps. So you as an engineer cannot merge if there's any findings. Well, you can ignore them, but we don't, we fix them. And just to, if I go and look at all the different systems we have, you can see that these are all the different systems we have, and there's pretty high code coverage on all of them. You can see here there's duplication, there's some, but there's no bug vulnerability or code smells in any systems. So pretty cool, and this is running every time we do a release.
And that's help us to always deliver a really high quality product, right?
It's not a guard. It helps. It's not a guard against, you know, common sense and pair programming and all that, but it definitely, you know, makes sure that you don't do these stupid mistakes that a computer can detect.
Yeah, definitely.
So all this happens every time we have a pull request. But
and inside the build pipeline, I think we passed it through it. Can we take a peek inside the build pipeline?
Yeah, but actually, okay. Let me look. It runs on the pull request, but let me actually go back to the work item here. That is, whenever it's merged down to main or master, it actually kicks off a deployment first to our testing or QA environment, then to our staging environment, and then to our production environment. And if I go in here to the production environment, you can see the first things that happens is that it kicks off a full build. So I think what you are asking to is, if I go into this build.
Yes, exactly that.
Here I can see all the different things that happens. So first there's some security checks. There's some versioning to make sure that every single build has a unique version, which is tagged in Git, and we publish files to CDN. And I can deep dive into the build itself. So as you can see, the build took, I think it was here, it took 8 minutes in this case, or 7 minutes here. And if I look in, you can see there's a lot of different things happening. There's some code analysis, the static code analysis that we just showed you. It's fairly slow. It actually takes all the time, almost all the time. But still, in parallel, we have different things that's running, like build artifacts and different components in our system. And we also have this very interesting things here called Resharper lending. You may know Resharper, which is JetBrains developer tools. We use that to develop. And there's a lot of code conventions that we have enforced, like spacing and using var over the types, right? Over the types. It can be how we name our parameters and variables and so on. And this is running every single time we make a deployment. So you cannot even make a deployment if you are not following our code conventions. So
awesome.
Yeah. So
and that should run forever, right? Because one is running for 6 minutes, 7 minutes, 4 minutes.
So I'm not sure what you mean.
Yeah, as each task inside the build, they run for over 5 minutes. So all those collections should run for what, in a half an hour?
Well, as I showed you,
right?
Yeah, because as I showed you, the final, the entire build took like 7 or 8 minutes. So they run in parallel to make sure that we speed it up.
All build workload.
Yeah. So after the build is run, we kick off a release. And some of you who are DevOps fans might say, why are we using the release pipelines to doing a release? Because if we use these Azure pipelines, you have the YAML files and version controls. And you would be right. That is the direction Microsoft is or was going, at least. But one thing we get by using the release pipeline is this very nice integration that I showed you, where I can click, for instance, here on the QA, and I can see what work items are deployed. So I can go in here and go back to the work item, and it's kind of like I'm going in circles right now. So I'm back to the work item, and from the work item I can go back to release. So I can navigate both from the pull request to the work item to the release, or from the release to the work item to the pull request. So it's all kind of tied up, and that's what you get when you use these release pipelines, which you cannot currently get with the Azure pipelines. Then we have the deployment to QA. So after the build succeed, we deploy to QA, and you can see there's a small pre-deployment check here, which means that we cannot deploy to QA unless the work item state is in resolved. So this happens semi-automatically when you complete the pull request. When you create the pull request, the work item goes to code review. When you complete the pull request, it goes to resolved. But if someone tampered with it, it will not deploy to QA. So it must be in resolved. Then we can also see there's a requirement, sorry.
No, it's fine. Like, it's really exciting to see all of that. I just don't want to interrupt. So okay. Yeah, let's just continue.
So here you can see there's some work items, or another check that says there must be release notes. So if I go back to the work item that is behind this deployment, you can see there's some release notes here. And I'm actually not sure. I think I ended up on a different one than I started out with after all. But never mind. Here's some release notes. And I can take this number here and I can go into our wiki. And all these, every time we do a deployment, we publish the release notes to our wiki. And we also publish them to a Slack channel.
So the release notes that all engineers need to add for each change, it's not there just for silly documentations, actually being piled up in a common area inside this product here, inside this wiki page, right?
Yeah, exactly. So you can go in here and then you can have a full list of all the changes we have. So actually, going back to the original task that we started out with, I'm not sure how I ended up on a different one. I'll just go back to the release here. So now it's running on QA, and you can see that here we are also running the end-to-end test. But in the case that is actually failing, we have a video recorded. So I'll just go to a failed build, because only if it fails will we do this. And here you can see the same thing happened, but there was one test that failed. So I will click in here, click in here actually. And what happens is that it runs some smoke test, as I explained before, and there is a file, an MP4 file recorded. And I have actually downloaded this, and I have, and I'm going to play it for you. So the first thing you can see is that it starts by loading some tests, and then it says, okay, let me initialize a new tenant, enable all the modules, invite some users, and then we'll log in and we'll start navigating through the different parts of the system, just to make sure, once again, that we didn't break anything before release it to production.
And if there is any break, this is going to also help the engineers to debug what actually went wrong, right?
Exactly. So as you can see here, it's navigating extremely fast through our system. And eventually, I think if we go in here, you will see that.
We have an error. Okay.
He had failed, there was some timeout, and now the engineer can say, okay, it seems like it's called get authentication method, and then they can use this to start debugging the system. So coming back to the original release, it's now deployed to QA, we have the end-to-end testing, then we deploy to a staging environment where we can do some final regression tests. So this is the place, this is the last place where engineers have a chance to actually stop the release. And when they're happy, they can click on approve. So this is something that happens with, they get an information, a message on Slack where they can just approve it directly from Slack. And, and again, when we click this approve, it will then kick off a release to production. And when this happens, it will take the work item that is behind this release. And actually, you can see there's two work items in this one. So it started out by kicking off by one, but then it ended up by two. This is how I got confused before. So it's actually releasing two things. But these work items are automatically move to close when we get to this place. And then the release notes are published to our wiki at this point.
Automatically, right? So as soon as we approve, it's released, work items, close it.
Exactly.
Job done.
And now we said that we are doing deployment, I think like 20, 30 times per day. But we are actually only deploying to what we call prod 0. And this is where we run our own tenant for Templafy, we run our partner tenants, we run our demo tenants, but we also run a lot of real customers, but only
small ones.
Only the small customers. The big enterprise customers are running on the other environments here. And as you can see, this deployment was 3 hours ago. And tomorrow, actually, it's Friday today, so tomorrow is Saturday. So normally it's the day after, but this is on Monday. And Monday it will be deployed to prod 1, 2, and 3. And these clusters here, so this cluster here is running in Europe. By the way, this one is also running in Europe. So both 0 and 1 are running in Europe. 2 is running in US, and 3 is running in Australia. And as you can imagine, we could add South Africa or South America here. And as we grow, we will probably add more and more clusters so we can deploy.
And most probably with really low effort, because as you mentioned already, we are working with Terraform. We can just release infrastructure as a code and then just attach one more cluster here, and it's going to release it, right?
And this is also all automated. So this is something we will probably show you in a later episode how we built this, because spinning up a new cluster is literally just a few configuration parameters, and then boom, here we go.
May I make one question? If we have a situation that I have a bug that was discovered on production and it released, do I need to wait until the next day to have it released to Europe, US, and Australia?
So if a bug is marked as high or critical, or if it's an incident, we will just push it directly to all the different clusters, because this is just a safeguard to make sure that if there is a bug, there's an incident, we will most likely find it on prod 0 before we push it to the other environments. But if we find a problem here, we will fast forward all the way up. And the thing to say also is, to mention, is that we don't roll back. What we do is that we do a patch forward. So we do this deployment many times per day. Everyone knows how to do it, and as I just showed you, it's pretty safe. So when we have a production incident and want to fix that, we just roll forward. This ensures that if we have, for instance, database schema migration, so we make a deployment where we add a new column and so on, then when rolling back, then the column was there. So it's really complex to roll back, while rolling forward, so to speak, is something we do 20 times a day. So we know how to do that.
Nice. And for the last, like all this process here looks like real mature and stable and on. Is there any room for improvement in all of that?
Yes, definitely. I mean, one of the things, as you probably already picked up, is that we run the end-to-end test both on the feature environments and on QA, and we have some regression testing here. But the plan is actually to skip these 2 steps here, because we already did this on the feature environment. So we have been moving towards this. We just want to make 100% sure that it's stable and we can trust the feature environment to find all the regression bugs we might introduce. And then we can skip these 2 and also this approval. So we will push on green. So that's the difference between continuous delivery and continuous deployment, where you simply just push directly to production when it's green.
So this as soon as a pull request is going to be fully approved and in green and all tested, we just ship it to production.
Exactly. So that's one of the optimizations that we are going to do. And we have been working towards that for quite some time, and we are this close.
Cool. Thank you very much. Everything was really cool. Would you like to say some last words before we wrap it up?
Only stick around, subscribe to the channel. We will post other videos like this showing off different parts of our platform. Thank you very much.
Nice. Stay tuned. See you on the next episode. Bye.